All right, so this is the turbine experiment 1, 2, 3.
Okay.
So these are the experiments we're going to run through, and pretty much we're going to be building this small little turbine here, and we're basically going to add some functionality so the player can interact and turn it on and off on a console, right? So the first experiment we're going to go over is just the introduction to complex game objects, right? How to parent objects, how to order them in the hierarchy in a proper way to where you can animate a certain object, but certain other parts of it will not move as well. Then we'll get into the second experiment, which is covering animations, how to actually add the animation to an object in Unity, and how to transition between the different states. And then the third experiment will be covering trigger volumes and how to interact with the player, as well as how to play audio when that scripted event has happened. All right, so I'm going to go into Unity, and here I've got my hub scene loaded. So I'm going to be working on the wind turbine, so I'm going to go to my project here and see scenes, IND2. We have our wind turbine. I'm just going to drag and drop that right in the hierarchy. You don't have to, no.
No, I'm just saying, like, for this side, what you're doing right now.
If you want to follow along and you want to keep up, you can. But otherwise, I'm just going to be running through exactly what's in the document. So it's just a live demo of what you'll be doing. All right, so we got our both scenes in there. So I'll make sure I set my wind turbine itself to the active one. And now the first thing we need to do is actually create the wind turbine, right? Build the pieces that we need for this object. So first thing I'm going to create is just a simple sphere. So I'm going to game object, call this pivot. Drop this back down here now. All right, so now in our position here for our transform, we're going to go ahead and zero all this out. So anytime you're building a complex game object like this, you want to start out at the origin. I'm actually going to unload the hub for now because we only need to be working in this scene until we're testing with the player. So now here's our sphere here. I'm going to call this pivot. And now you see the transforms here are very clean, right? 0, 0, 0 in position and rotation, and our scale is all set to 1. That's going to ensure that our object is actually moving and rotating how it should. So the next thing we're going to need is some blades for our wind turbine. So I'm going to go ahead and create a capsule. Call this blade. All right, and now I'm just going to change the scale values here. Again, put this at the origin, 0, 0, 0. And now we're just going to change the scale to be 3 in the Y and just 0.25 in the Z, just to make it appear to be, flat like how it would be. So now let's just go ahead and duplicate this 2 times. So we have 3 total blades. And now we can go ahead and take all of them. So if we hold Shift and select multiple game objects here, we'll select all of our blades. Now we're just going to go ahead and drag them and drop them right into that pivot object. All right, so now you can see if I select the pivot object itself, I move it, everything's moving with it. So now the blades are children to the pivot, right? Or the pivot is the parent of those other objects. So now we just want to get these, question? So now we want to get these blades into position how we want them. So we can start to just move these and rotate them how we'd like. But you'll see this global and local button up here at the top. And this is going to be really helpful. So if we start to just rotate these, so let's rotate one 60 degrees in the Z. And then select another one and do -60. You see now it looks like this cool sunflower flower shape, right? But it's not quite how we want it. We want to be, something more resemblant of this right here, where we have, the blades are coming out of the center pivot object. So you'll notice now if I go to move these, the axes don't line up with the game object itself, right? So the up or the the up transform of this game object is pointing this direction, but the pivot is pointing up in the world. So that's what this button is helpful for. So I can change from global to local. So you'll see when I click that, it actually changes that widget, right, to actually go along the vectors of the normals of that object itself. So now I can just start to move these into place how I want them. All right, and now that's more representative of what we want for our final object. So now we want to go ahead and definitely test it. Make sure nothing went wrong, because sometimes with scale values on certain objects, or if you have a rotation value on something, things may not behave as you want. So definitely notice that your pivot object itself hasn't changed any of those values, right? It's still completely clean with 0 for the position, 0 for the rotation. So let's go ahead and just test it. All right, cool. So everything's behaving like it should. Everything is following properly. So now we can move on from here. So the next thing we want to do, and also I'll point this out, if your object isn't rotating properly, it could be that your object is rotating from the center. So this is a good example of the difference between the pivot and the center if you're in a complex game object like this. So when I go to the center, it's just finding that average location, that middle point of all of those game objects, and putting it in the middle there. So you can see it's the middle somewhere by this blade. So it's not quite what we want. But if you toggle to pivot up here, which we talked a little bit about this button already with the level blocking meshes, going from the center of the object to the actual pivot point. If you hit pivot, it's going to go to the pivot point of that sphere itself, which we all know with Unity primitives, the pivot and the center is the same thing. But center, with multiple game objects like this, is just going to go to the center of all of them combined as a group. All right, so the next thing we need is just a base for this object to rest on. So let's go ahead and just create a 3D cube. All right, and we're going to call this head. Head here. All right, and again, let's just zero all this out to make sure it's at the origin. Now we're just going to move it into position.
This is a 3D game object cube and not
Yeah.
Level blocking?
Yeah. You can use level blocking meshes for this, but really anything that the level blocking meshes are truly designed for just usage of like static objects in the world. So a lot of this you can put on here as level blocking meshes, but things that are animating or moving or simple objects like that, you want to stick to the Unity primitives for simple reasons, just to be able to prototype them quickly. And again, that center versus pivot, it definitely play a part for anything that's being animated. So there's our head object. Now we're going to just go ahead and create a cylinder. Let's call this stalk. All right, and now I'm just going to scale this up. Again, put this at the origin. Let's give this, I don't know, a scale of 15. It's really up to you how tall you want yours to be. Let's go with 10. I'm just going to move this into place right where I want it to be. All right, so I got my head and my stalk, right? But now I want those to be a parent-child relationship as well. So if I move the stalk around, the head will go with it. So again, I'm just going to take the head and drag and drop it into the stalk. All right, so now you can select the stalk and move it around, and that should be good to go. You shouldn't have any issues with that. Now from here, we want to group all of this together, right? So we want to be able to take this whole object and plop it in the world somewhere and not have these separate pieces, right? So right now I have the pivot, right, and that moves around. I have the stalk, and those move around independently. So what we're going to do to combine these, right, is just create an empty game object. So I'm going to select the pivot.
How big do we want our stalk?
It's up to you. Mine is 10 right now. Just something so you don't have to look too high up when you're testing it. So between 10 and 15 usually, or 5 and 10 is fine. So what we're going to do is create an empty game object to put all of these into, right? Just a container to hold all of this information. So if I go to the pivot and I right-click and create empty, the reason I'm selecting the pivot is it's going to put it in as a child of this object, which we don't want. But one thing that we do want is we want this clean transformations like this. So you'll notice if you create an empty game object on the object you want, it's going to create it with that position and rotation value. So it's pretty much creating it at that location that you want it to be at. So now I'm just going to call this wind turbine so we can keep ourselves organized. All right, and now what we want to do is take our pivot and our stalk, right? So just hold control and select them. You don't need to select the children, just the two parents. We're going to drag those, and drop those into the wind turbine itself. All right, so now if I select the wind turbine and move it around, everything should go with it. Everything is one cohesive, consistent game object. And then again, let's just do a test to make sure we didn't break anything. Always a good habit to get into. All right, that looks good. The stalk and the head isn't moving. Things aren't getting distorted with any scale issues or weird things like that. So that looks good. All right, so then the next thing we want to do is you'll notice if I go ahead and wanted to add this to the level, right, if I move this around, it's going to be moving from that center point. But we don't want that necessarily. We want to give ourselves more control to where we drop it in. The pivot is in a location that's helpful and beneficial to us. So what we can do is move the children objects into place. So I'm going to go ahead and select the pivot and the stalk. Again, just hold control and select both the objects. And now I'm just going to start to move them. So one thing to pay attention here is when we move the children in a game object, the parent isn't changing at all. We're just moving the objects inside of this game object. So notice that this wind turbine pivot is right here at the origin. So now when I start to move these objects, this up, and now I pretty much just want to get this base cylinder right at that origin there, or as close as I can. Right, so now it's in place. Now if I select that wind turbine object again, notice that my pivot is still there at the ground. So that's really helpful for basically setting up where you want your pivot, because now if I were to go into my folder here, and I'm just going to go ahead and again, I like to, for the sake of this assignment and for you guys learning how to work with Perforce still, I like to just create a new folder for everything. I'm just going to call this entryway, or I'm going to call this wind turbine. So everything we create for this experiment, I'm going to drop in this folder. And that way, when we go to Perforce, we can very easily just add this folder and work out of this folder rather than trying to manage the whole project. So now with our hierarchy, I'm just going to drag my wind turbine here and drop it into this folder, right? Basically just creating a prefab. And the reason why I wanted to show this was because now if I go ahead and drop this back in the world, you'll see that that pivot, it's coming in at that pivot. So it's very easily able to snap to the ground. And it just makes your life a lot easier when you go to actually place these in the world. So again, let's just go ahead with our game object here. Just double check and make sure everything is rotating properly. All right, looks good. Nothing else is moving. So again, let me just go ahead and move this. I'm going to move this onto our platform now, because now that it's at we have the game object how we want it. We're free to move it wherever we'd like. Just going to move it onto our platform here. Give us a little place to test our work. And that's the beginning. That's the first experiment. So I'm just going to go ahead and save my scene. And so what did we do, right? That's always a good thing to think about. What are the changes we made? So I made changes to my my wind turbine scene, and I also added this prefab in here. So I'm just going to go ahead and save the project.
Just under assets, or is it under
Yeah, I just put mine right under assets. If you want to put yours in another location, that's totally fine, just as long as you know where it is. It'll make working with Perforce a lot easier. So now I'm just going to come back to Perforce. Make sure I'm on the right server. All right, so mine is in, I think mine is actually in your working folder with you guys. Yep, so here's mine. It's my project. So scenes, right? So I'm going to select the IND folder and I'm going to reconcile because I know my scene that I've changed is inside that folder. So there it is. It found that modified file right there. It found that the wind turbine scene. So it's going to check that out for me. So go ahead and hit reconcile. Okay, so that's been added to my change list. And then also, I know inside of my assets, I should have another folder. There it is, wind turbine experiment. And you'll see those blank pieces of paper there to show that it's not yet on the depot. So I'm going to right-click and mark for add. All right, that looks good. And also make sure you pay attention to that even the folder itself has a metadata file. This is important that you also add this to the depot. So I'm going to mark that for add. Now that those are all up there, I go ahead and hit submit. Just going to write a change. I did it on the scenes folder, or on the IND2 scenes folder, just to find that scene that we worked on. And I'm actually, for the sake of this experiment, and just so everyone doesn't fall into using reconcile offline work as a crutch, I'm just going to go into this folder here, and I'm going to check out the scene and the meta file that I'm going to be working on. So I just want to make the point that you don't have to use reconcile offline work. It's better to actually use this checkout system to actually understand version control. Not all version control has this reconcile offline work, this basically this magic button that you don't have to worry about using Perforce. If you get a job and you're using Bitbucket or Git or Mercurial or some other version control, it's good to understand, how it basically works. And then from there, you're able to apply the knowledge from one into another, just like it would be a game engine or a 3D modeling software or anything along those lines. It directly all translates. You just want to learn the steps first. So I'm going to check out my scene just to showcase that you can work this way, and it's definitely recommended. All right, so that is the end of experiment 1. Anybody have any questions at all about that stuff? I can give you guys a few minutes to get caught up if you'd like. Same thing goes for any of the online folks. If you have any questions, feel free to shout them out. No?
So were you doing the entire wind turbine assets folder?
What do you mean?
The experiment? Like the entire folder experiment?
Yeah, you can just mark that for add. Yeah, because right now you should just have the prefab in there.
Which is like 6 files?
What are the 6 files in there?
The parts of the pivot and the stock, I'm assuming.
Those are just in the folder itself. You should just have the prefab.
Yeah.
Yeah.
Hold on. Mine just did it wrong.
Yeah, I mean, unless you open this up and you're seeing all these.
No, I have the prefab, but it's like 6 parts.
On Perforce?
Yeah.
Alrighty, so on to experiment number 2. This is definitely going to start to ramp up in difficulty and involvement. So if you have questions, definitely please stop me during this one and experiment 2. Because I've been doing this stuff for a while now and definitely running through these several times. So if something isn't clear, please stop me. It's really important. So in the second experiment, we're going to be going over how to actually animate the objects and how to set up the animation states in Unity. So we're going to cover the difference between the animation window and the animator. Those are two definitely very different things, but really powerful and good to know, the ins and outs of. All right, so we have our scene here with our turbine. So the first thing we want to do is come up here to the window tab, and here you'll see this animation window. This is where we're going to start. So window animation, and it pops up this window. So Unity is really nice with their descriptions there, basically saying no animatable object selected. Does anybody have an idea of what we need to do? Max? Not quite. Don't overthink it.
right?
Okay, what it's basically just telling us here, no animatable object selected.
So we have to make it animatable.
We just have to select the object we want to animate, right? So, so we'll go to our hierarchy and basically, so what is the object that we want to animate here? The pivot, right? We've set it up that this is the object going to have our motion. So now you'll see if you select the pivot, this will change and it'll say, to begin animating pivot, create animator and an animation clip, right? So every object that's holding an animation needs an animator. That's what's going to hold the different information, how it's going to transition from one animation to the next, and it's going to hold that information in that actual asset. So I'm going to go, question?
Yeah, did we need to check out the windmill experiment?
The scene?
Yeah, no, the scene. I got the scene checked out. The
Meta file?
prefab.
No, you don't need to. No, because we're not going to be working on that.
Okay.
I just wanted to showcase why you have the pivot there. At the end, we're going to update it with a newer version of the prefab that actually has the functionality built into it. All right, so I'm going to go ahead and hit create here. So then this window will come up basically, where do you want to save it and what do you want to call it? So I'm going to have mine saved, again, have everything saved to this wind turbine experiment. And it's asking for the name of this animation. So I'm going to call this one idle. All right. And now another thing to probably notice and pay attention to is that this object here, this is the actual animator itself, or the animation controller. This is important itself. And this image here, this is the clip. This is basically this idle animation. What's the movement? What's going on in here? And once we do a little animation here, we'll be able to preview this here. So this icon here is the animator, and this is the animation clip.
I'm sorry, I'm going to go behind. Did we select the blades as well as pivot for the animator?
No, just the pivot. All right, so here we are in the animation window. So here is basically where you can select your different clips when you're working on them. And now what I'm going to go ahead and do is add a property to this, right? So what is it that we want to animate on this object? So we all know that we're going to be animating the rotation value, right? So it'll be transform rotation. But also just pay attention to all the other goodies and objects we have in here. So we basically have access to all the other components of this game object, right? We could animate the collider if we want to. We can actually animate if it's enabled or if it's a trigger volume. We can animate the radius to make it bigger or smaller. You have a lot of control over this, as well as take a look at these guys down here. Right? We have the 3 blades. So we can actually animate the children objects of the game objects that we're animating. So this isn't applicable in this scenario. We're just going to be animating our pivot object here. But say, for example, on your entryway, you have your door swing open, but you have your handle, the actual handle on the door, be a child object to the door itself. So all in one animation, you can have the handle rotate down and then the door swing open. That would just be one animation because you have access to these children objects. And I'll show you an example at the end of class of one that an entryway I've been working on that really showcases you can do a lot with just all the children and how you set everything up. So a good rule of thumb is always build the object first and then plan out what the movement's going to be, set up the hierarchy first, and then go ahead and start animating. All right, so we're going to do the rotation. So you go ahead and hit this little plus. Now you'll see that this line comes in, and this comes in with 2 keyframes. That's what Unity uses to represent these objects here is these keyframes. So there we go. We're done. We are now animators. Congratulations. So we have our idle animation. Yes, you do. So if you drop this down, we'll have actual different values here for the X, Y, and Z rotation that we can adjust. And then down here, you'll also notice at the bottom of this window, this dope sheet and the curves. And you're probably wondering what the difference is between the two. So the dope sheet is only going to show you basically the keyframes that are resembled on the timeline. So up the top here, this is what's called the timeline. It basically shows the time. These aren't seconds. These are basically parts of it. So this is 1 second right here, from 0 to 1. And then these are all just integral or ticks along this 1 second here. So some controls in this window. If you middle mouse click and drag, you can go left and right on the timeline. If you hold down Alt and scroll wheel, you can make your timeline larger to give you a bigger animation. So if you want to have a cool, intricate animation, don't think you need to cram everything into 1 second, because by default, Unity is just going to give you 1 second. Also, if you want to drag your animation out to make it larger, you'll notice how part of this timeline here is gray, or light gray, and then over here it's dark gray, and if I hit play, it's just going to stop at that 1 second. To make that longer, you actually just take this final keyframe and drag it out, and you'll notice that it now is longer, an actual longer clip. All right. A few other things of the controls. Here's obviously this play button. This will allow you to play, basically preview and play the animation itself. And also this record. Be careful of this record button, because if this is on, anything that you do in your scene is going to be recorded and actually be, like applied to your actual animation. So you can't undo this action. It's just if it's recording, Unity is keeping track of what you're doing. So just be conscious if that's on. So yeah, if you, what? Yeah, you start to move it. Yep. So then basically here along this timeline, I like to use the term that's very common with artists is called scrubbing. So you'll scrub through your timeline. It's basically just dragging this red bar back and forth to just basically get a sense of the motion and previewing it. And this will be much more clear when we actually add some motion to our object. But right now our idle animation is basically just this in the off state. All right? Are you clicking in the actual time? You have to click up here in the time. You can't click down here in the middle. Alrighty, so here in the curves, hopefully you guys like math, because part of animation, a lot of it is just reading graphs. Everyone understand what a tangent is on the curve? Right? So when your tangent is 0, or it's, your line is basically flat, there's no change, that means there's no motion or change in your animation. Right? It's just go here to here, these are the same exact values, and it's just very flat. So to always think about your motion and the tangents and how they can be equivalent to each other. If you have a sharp tangent or a very large slope value, that's a fast movement, because it's basically distance over time. It's moving very fast, or it's moving over a short amount of time. So always use the tangents themselves to actually gauge the motion. So if you just go ahead and look up like animation spacing or animation timing on Google, you'll get a lot of these different, these little different graphs and things like that. And like some of these have basically been used by Disney, the 7 old men of animation for decades now. Basically all these principles. So it's good to just understand some of this. Just like UVs, you guys don't have to become master animators or things like that. But being able to understand some of this stuff and apply it on your own can definitely be very, very helpful. So take a look at this little graph here, and take a look at, let me just go to the image. So this basically, what this represents is the spacing of your keyframes, right? So this is very even. So I have even keyframes that they're all moving in equal distance, and you'll notice the motion is very smooth and even. Basically the line would be pretty much just a linear line at this point. So this one at the middle here, notice how they're very spaced out in the beginning, and then they're closer together here. So what does this tell you guys? Yeah, right? So the farther they are from each other, the faster it's moving. The closer they are together, the slower it's going to get. All right, and then down here it's a little bit of both, where it starts out really slow because they're close together, and then they move farther and farther apart, so it gets faster. And then here it basically does this little overshoot and this little wiggle to give us a sense of it stopping. So this is probably a lot to take in, but you can start to understand how this is being applied to a graph, right? Because this would be like a linear curve. This would be like part of a sine curve, right, where it's coming up and then basically peaking at the top here. And then this one at the middle would be at a different point, where it's starting out slow, coming down sharp, and then flat again. So take a look at some of these as well. It could be helpful to you. A lot of this stuff is 2D. but when I went through school, a lot of it was you learn everything in 2D. The very first animation class I had was 2D animation, and it was literally this was our assignment, is make a bouncing ball and understand, you know, the spacing between them to get it to make it feel heavy and then it's dropping and bouncing. So if you understand the principles in 2D, it's directly translatable into 3D because a lot of it is just reading graphs. So besides that tangent, and animating is by far my favorite discipline from art. I think it's probably the most technical. It's because it's a lot of reading graphs and adjusting numbers and things like that. So that's my wheelhouse for sure. So now we have our idle animation, and always go ahead and play it. Make sure you don't have any weird wiggles or wobbles or something may have gone wrong with if you had the record on by accident and you bumped something. And also notice,
Yeah.
yeah.
How do you erase the recording?
Then you can just go to the actual keyframes themselves and then just delete them. Or go to the keyframe and just edit the value. Like here I have this 0.01 value. I'm just going to go ahead and hit 0. Then slide all the way down here. And then hit 0. So you'll notice that the buttons here change red also on Unity when you are recording, just to give you a warning that you're actually recording information. So now that I've got my idle animation, this is basically going to be our off position because we're basically going to be able to turn this wind turbine on and off. So I'm just going to call this one idle. And now I'm going to create another clip. I'm going to call this one spinning. So everyone can probably guess what this animation is going to be. So I'm going to go ahead and add a property, add a transform, add a rotation. All right, so now by default, again, there's no motion to it. It's just going to be hanging out there. What we want to do is add some rotation value to the y-axis? No, to the z-axis. So now I'm going to come to the 1 second mark where my keyframe is, and I'm going to select my value here, and I'm just going to type in 360 degrees. And I'm going to hit play and see what happens. So now you should have a motion like that where your wind turbine is spinning, and it should be seamless and should be looping because basically when it gets to this point, it's 360, it comes back to here and it's at 0, and it starts all over again and loops over and over again. So now I can start to make a little bit more sense of our graph, right? So here's our graph to where it's completely linear, it's constant motion. So if I wanted to make this spin faster, what can I do?
Shorten the ending section, the last.
Shorten the distance.
Yeah, yep, exactly. Yep, so I move the keyframes closer together. So I go ahead and just take this and drag this over. You notice right now it's behaving a little weird. Actually, what I want to do,
Get the end.
yeah, because I only grabbed the value that's changing. Let me go ahead and
I don't think it worked very well first.
let me go to the dope sheet itself, and I'm just going to grab all of these. Because there's keyframes on the X and the Y. We honestly don't need them because the only thing that's being changed is the Z value, but Unity likes to put a keyframe on every attribute in the property that you're adjusting. So I'm going to go ahead and just drag this to 30 seconds. Now you're seeing it's spinning much faster, right? Because our slope is much sharper and the distance it's traveling is still the same, but the amount of time that it's doing is longer. So if we wanted to slow it down, you know, we do the opposite. Take this keyframe and drag it out. And now it's going a lot slower. So another thing I'm going to talk about that not directly applicable to this assignment in particular, but the entryway is definitely very helpful, as well as just all of your animation principles. So again, we're talking about tangents and how the curve affects the motion. So if you go ahead and right-click on these keyframes while you're in the curves section, you actually get control of the tangents. So Unity likes to just default and put it into auto. Anybody want to take a guess of what flat means?
Flat.
It makes it completely flat, right? It gives it a tangent of, gives it a slope of 0. And then down here you basically have control of the left and right tangents, as well as having control of both. So maybe you want the left one to be constant or linear, and then the other one you want to have it be free and have control over it. So if I go ahead and make these flat, you'll notice what happens. Let me just isolate the z-axis so you don't see the other ones. So this would be more indicative of the of the middle of this one right here, to where it's starting out slow, it gets really fast, and then it slows down again, right? So by reading the graph, right? Slow amount of movement, it gets sharper, sharper, and faster, and then slows down. So let's just go ahead and play this. So it looks a little funny because it's a looping animation, but you can see there where it starts slow, it's slowly starting up, and then it's doing its motion, then it slows down until it comes to a stop. And then what you can do is just start to mess with this and really like have fun with it. So you'll select the handle. Now once you change it from free to, or from auto to a different type, you'll see these little handles. You can go ahead and grab the handle and move it and see how it affects the motion. So this would be it's really slow, and now it's spinning really fast. So this doesn't necessarily work in a looping animation, but understanding these different controls and different adjustments can definitely improve your animation and add that that extra layer of polish and detail to it.
Question.
Yeah.
So pretty much with that function right there, like if we wanted like make a scene with like using the wind turbine and like showing that the winds start changing at different speeds throughout the time, that would be a good time to use that.
Yeah, definitely. Yeah, you would basically have it, if it's coming to a stop or slowing down, you would have it at that point, and then if the wind's picking up faster, you have the motion be a lot faster during your animation itself. All right, so I'm just going to get this back to linear because we want this to be a completely looping animation, so you can't see where it starts and stops. Right, it's just going to loop through this over and over again. So those are our two animation clips we're going to be working with. Anybody have any questions about the animation window itself? No? All right. If you have any, definitely ask away. So one other thing before I move on is you'll see that these two buttons up here, basically if you want to add a keyframe, go back to the dope sheet. So if you want to add a keyframe, right, you can click this little button and it'll add it in there for you. You have a question?
Go ahead.
You can also just start to, with the record on, you can just start to move the object and you'll see the keyframe comes in there for you as well. What's up?
That'd be like if you want to have the door open and then close. Like, so it'd be a change in direction of the animation. So it's not moving.
Yeah.
So
Well, we're gonna get to transitioning between different states. I'm just talking about if you want to add more detail or more control over your animation. That's how you can add keyframes to the. I think you can also right-click and add a key. So the other thing I'm going to cover real briefly, and then I'm going to go over this again probably next week a little bit, is these animation events. What these are really helpful for is you can add an animation event to your timeline here, and basically what this does is if you have a script, if you put a script on the same game object, so mine is on the pivot, I can pretty much call a function during my animation. So say halfway through my animation I want something else to happen, like trigger an explosion somewhere else, or turn a light on, or animate a button from yellow to green, or from yellow to red. You can actually include that information in your timeline. So I'll show you a few examples of animation events, but that's really what they're useful for, is basically any type of function or additional interactions that you want to have in your animation itself, you can do through basically calling these scripts at a certain point in the animation. So you can do this with playing sounds, particle effects, triggering something, destroying some game object halfway through. Really, it's up to you. It's basically, if everyone understands what a function is, you can really just call any function you want at any point during your animation. And I'll give you a few examples towards the end of class, and then again next week. All right, so how did this get here? We don't need this. Get out of here. All right, so just double check before I move on to the animator. Idle looks good, not moving. If I drop down to spinning, that looks good to go there. All right, so now we have our animations, right? We have the clips themselves. So here we'll see the idle animation, the spinning animation, and then here's that pivot animator, right? The animator controller. So now I'm going to go to Window Animator, And now you're going to see that Unity has done some work for us already. So pretty much every animation clip that we create, there's a state that goes along with it. So what I want you to understand the difference that these ones down here, these are clips, and these ones over here, these are states. Basically, that what state is this object in, what animation is going to be playing, because in this state itself, you'll see that here's the motion. This is where you plug in which clip you want to have playing at this time. So basically every time you create a new animation clip inside the animation window, Unity is going to go ahead and just default and create one of these states for you. So this entry state, what this is used for is basically when the level loads or when this object is awake or initialized, this is the state it's going to start in. So if you're playing through your level and then you're like, say you have enemies spawning or you have something, you know, basically when that enemy spawns, what is the state it's going to enter in as? So you can set that. And also if you just right click and do set state machine default state, you can drag this arrow to basically change it if yours isn't already connected to the idle. And then somewhere around here, it always hides from me every time, there it is, there's an exit state. So this one is definitely basically the same thing as the entry, where if this object is destroyed, it's going to exit at this time, or yeah, it's pretty much the same thing, to where this is the final state it's going to end in, and then it's going to exit that final state. Not as useful in my experiences as the entry. I think this one's definitely more important, but the exit is definitely there if you want to have that as well. I think what this is also used for is basically you can have sub-states, or you can have multiple layers to basically where, like for example, one that's super common is if a player is walking, but then they enter a water volume, and now there's a whole new layers of swimming animation, right? You have swim forward, you have swim left, swim right, swim back. Maybe you have a dive down animation. You have basically a whole new system for that. Basically, you would have a new layer, and you would exit this basically default walking state and enter a swimming state. So stuff you guys may never utilize, but that is what's there, and that's what these layers are for, is basically transitioning back and forth. But we're not going to mess with those. We're going to worry more about using parameters. So pretty much what's happening now is the level is starting and it's going to this idle state. So what we can do is we want to add some transitions to go from the idle to the spinning state, or right, go from the off state to this on state down here. So you can just right click on the object or on the state itself and do make transition. And now you'll see this little arrow. Now you can go ahead and it'll snap in place and then click where you want it to go. And now if you move this around, you'll see that arrow will follow with you. So this is always my favorite part, because what I'm about to talk about is there's transitions and there's also conditions. Super, super similar, and makes it difficult to say over and over again. But so this here we've added, this is a transition, right? Changing from the idle state to the spinning state. So we're going to go ahead and add in another one. Right click, make transition. And now, so Unity doesn't give you the option if you make a mistake or something, you can't just right click and delete. You actually have to go on your keyboard and hit function delete, and then that way you can actually delete the state. It's a common question I get. So pretty much now what we have in our level, let's go ahead and take a look and see what we've got. So I'm going to go back and drop in the hub. That wouldn't work. All right, so I've got my hub in there. Let me make it so you guys can see the animator. Okay, I'm just going to go to the scene view.
I have a question.
What's up?
What if you rotate the window after you created the animation?
That shouldn't matter.
So like you take the entire prefab, and rotate it 90 degrees.
Yeah.
Does the animation change too? So
No.
It's now rotating on a different axis?
No, I can go ahead and rotate this like that.
I guess it's because you're rotating the pivot and not the empty object.
Exactly. So if you put your animator, so that's working how you want. If you put your animator on, so the question was that if you rotate the if you rotate the wind turbine, is the animation still going to work, or is it going to rotate as well? Is it rotate the wrong direction? And the reason is that it's not, because we're rotating this pivot object. This is what we're animating, and we're rotating this wind turbine. If we were to go ahead and put our animator on this, then yes, that would cause problems with the animation itself. So that's why you always want to put your animator on an object that isn't the highest in the chain, because that way we can go in and start to make multiple of these, and they're all independent of each other. So definitely a really good question. All right, so you'll see here that, here we go, this auto live link sometimes doesn't work. I don't know why. I have it checked on all the time, and I don't know if anyone noticed before, this wasn't looking like this, and now it is. And I'm glad it is, because this showcases what's going on. So this will show you, basically this blue bar is showing you it's playing through this idle animation. Then you'll see that blue line light up this transition. Then it's transitioning to the spinning state. It plays through it once and then goes back to idle. Right? So this is showing you it's transitioning back and forth between them. But right now that there's no conditions set, there's nothing to check to see if we've actually enabled this, or if we are wanting to transition from one state to the next, right? So the next step is we want to actually add control so we can tell the system when to transition from idle to spinning. And one way to do that is using what's called parameters. So if you go ahead and hit this little plus sign, you'll see that these types here, and so float, integer, and bool, everyone should already be familiar with those terms, what those mean, right? Hopefully, yeah? Okay, cool. So a trigger volume, this is a little, or a trigger, sorry, I'm not going to confuse the two. This is a little bit different. Basically what this one can do is just set to happen at some point. So you can enter a trigger volume or enter something and just say, trigger this thing to happen, and that can be your actual condition. So those are definitely useful, and you can use those for your entryway or for other interactions. What's that? No, you're thinking of like on trigger enter versus on collision enter. This is more of a trigger. So you can say set this trigger. What? I think you're thinking of an actual trigger volume in the world, right? Or a collision of an object.
Yeah.
This is just a parameter to say set this thing to happen. So if we just go ahead and use a Boolean, I'll just call this toggle spin. So this is just basically something we can tell Unity, make this toggle spin true or false, right? And we have control over this. So with the trigger itself, you'll see that this one is just this little, basically this little circle here. You can basically say to, I'm just call this like turn on. So you could set this to be your condition to happen. So you could tell Unity, set this trigger to turn on, and that will turn on your thing on and off over and over again. So those are definitely useful, and I can show you some examples about why you'd use that over the toggle over a Boolean. But I like to use the Boolean for this example because it makes setting up the sound a lot easier. So you write a little less script when you're doing the set when you're using a trigger, but it makes setting up the audio. It basically forces you to using animation events for your audio. So that's one way you want to do that. I can go into more detail about how to do so. But here is this toggle spin Boolean that we're going to be using. So now if we go ahead and put this over here. So now you can see if I select these transitions, right, these white lines here, these are the transitions. And now I go down to this conditions. Here's my conditions. So this is basically saying what is it that I need to check for before I can actually transition to the next state. So here if you go ahead and hit plus, this plus sign, it's going to automatically find that parameter we've already built, right? So there's only one, so it's going to auto-populate that. If you have multiple in here, you can select a long list. And actually, let me go ahead and just create that trigger again to show you the difference. Turn on. So now if I select this transition here, if I can change this to turn on, you'll notice that there isn't a value it's checking for. It's just saying turn on. And you're basically communicating to Unity, turn this thing on.
So that would be get that two of them.
No, you just need one. You can basically have that one here where it says turn on, and over here you can again do the same thing and just say turn on. I know it's tricky, and it definitely is useful, but it definitely takes a bit to wrap your head around. That's why I like to just start out with the Booleans and just mention the triggers, because it's a little bit more, it's a new thing. It's a newer feature, I think, in Unity 5 or Unity 5.1, but they're really useful, definitely useful in certain scenarios. So I'm just going to start with the Boolean for now. Let's not screw around with this one. All right, so here on this transition we have our toggle spin is set to true. So this only is going to transition like this when this toggle spin is set to true. So over here I'm going to do the same thing, except I'm going to have this one be toggle spin set to false. So this is only going to go back to spinning when this turns off, or when that's basically set to false. So I'm going to go ahead and play again. I'm going to pull my animator over here so everyone can see it. All right, and back out of here. I'm just concerned with the scene right now itself. So, oh shoot, done goofed. All right, so now you'll see in my scene that it's hanging out in that idle state. It's just going to hang out there forever until I actually tell this toggle spin here that I want this to be enabled, or I want this to be true. So now you'll see once I click on this, it's going to transition into that spinning state. It's just going to hang out there. It's going to be spinning forever until I tell Unity to turn it off. So I turn it off, and it transitions into that other state. So a few adjustments you can make to your animation itself. If I select if you select the state that you want and go to the inspector, or sorry, I think the transition. Yeah, select the transition. You can do this has exit time. You can screw around with this if you want to make it so you'll probably notice that your idle animation, right now if you turn this on, what this is actually doing is it's saying you have to finish your entire idle animation before it transitions to the next one. So with this exit time, you can basically turn it off and have basically interrupt, yeah, and stop it at a certain point. Yeah, so it immediately just finishes the idle and goes to the next state. You can also play around with the, go back to the animator. If you select the conditions themselves, you'll see that this interesting graph here, basically how you'll see here at the end of this idle, it's basically transitioning into the spinning. So it's almost like it's playing both at the same time, like it's blending them between each other. You can take these little markers here and drag them to make it longer or shorter, and just play with this. I'm not going to say that, oh, you need to set it to 10% or 20% or some definite value. Most of the time I leave them default and leave it as is until I see something visually wrong, and then I'll go in there and try and correct it. So that's what the exit time does, as well as you can start to just drag these to shorten it or extend it how you'd like. So let's see.
It's funny when you had exit time on the
yeah, like it like loops real quick.
It goes really backwards.
Yeah. All right, so let's see. We went over setting up the animations themselves in the animation window. And then also we just talked about the animator themselves and how to set up the different states with the transitions. We talked about the parameters and the different ones available to you. So yeah, definitely keep in mind these different integers and floats, right? If you have an integer in here and you set the value to something, you could very easily set your transitions to be like, if this integer equals 3 or if it equals 5, you're able to go to this new state. That's definitely one you can use for, like, if something is locked and you want to actually unlock the door first and then open it, you could use that, or it could just be another Boolean, depending how intricate you want the system to be. All right, so I'm going to go ahead and save my scene. All right, let's go ahead and save the project. So real quick, come back to Perforce, everyone's favorite. So I got this scene checked out, so that's already good to go. And now if I look at my wind turbine experiment, up in the workspace side, you'll see that here's the animation clips that I added, as well as that animation controller that was created for us. So So here's these 6 files that we need to add, as well as these 2 files, the scene file that we've already checked out. Right, so I'm just going to go ahead and select these files, just showing you another way to do the same thing. I'm just going to take these and drag them right into my change list. So you see it, by dragging them into the change list, it recognizes them and it's going to mark them for add for me. So it found those new ones, it marks them for add, and also I have these other ones already checked out, so I'm going to go ahead and submit it. All right, got everything up there. So again, I'm going to be working on my scene, so I'm just going to come into the scene itself and check it out. All right, any questions at all so far? Any questions from the online students? No? All right.
How do you change the name of the file? I tried to.
On Perforce?
No, so I didn't name my idle. I named it Turbine Pivot, and now it's.
Like your animation clip? How do you change the name of animation clip?
Yeah, because I did that.
You should be able to just go here
I
and.
did that, and it just created a new one called idle. I'm like, what?
Oh, let's see.
Try changing yours.
I fixed it.
Let's try mine.
All right. So the third experiment we're going to go over is covering a lot of different things, a lot of different topics, but again, definitely stuff that is really applicable in a lot of different facets. So I know you guys have done some stuff in PNP1 with the generic behavior, and you guys are like introduced and exposed to like on trigger, and different trigger volumes, things like that, right? In Jacob's doing the Indian head bobble.
Yeah, sort of, and that's what we were supposed to do.
A little bit? Okay. So now we're going to actually go into, building this in Unity, and we're going to write a short little script on how to get that to actually interact. So let me pull this up. Too much stuff. Alrighty. So in here, we're going to be going over adding a trigger volume in Unity and allowing the player to interact with it. Also, we're going to add some audio, so when the player interacts with our console, we're going to provide them with some player feedback so they know that what they did was successful and that they were able to interact. And then also we're going to write a script to pretty much what our script is going to be doing in a nutshell is turning on this toggle spin on and off, right? Because we've already seen that in our game when we turn this on and off, that changes our states for us, right? That is what's causing this to play. So that is what we need to accomplish in our script. That's what we're going to be doing. So you're going to need for this one, you're going to need Turbine Experiment 03.unity, or did I lie to you? I think I did. Turbine Audio.unity package. This is the one you're going to need for this assignment. We just have 2 audio clips in there for you. So I'm going to go ahead and right-click, import package, custom package, IND content, entryway, Turbine Audio. Open. It drops in this. Basically, we just have these 2 files for you, the click and the wind loop, so import. And when I exported the package, I already put them in a folder called Wind Turbine Experiment. So if you've been following along, they should populate right into your folder for you already. If not, I recommend moving them into one central location so you don't forget to submit them to Perforce. Cool? All right, so now we have our audio sources. We want to go ahead and start to set up our control trigger, right, or our system for the player to interact with. So let me go ahead and where'd my hierarchy go? There we go. All right. So I'm going to turn this back around. All right, so I'm just going to create let's create a level blocking mesh. All right, you can do like a sphere or a capsule, whatever you want. I'm just going to make a little control panel here. So something to represent where the player needs to go to interact. So let's definitely keep everything named. Control station. All right, and now in here, what we're going to need is an actual trigger volume. So I'm going to right-click on the control station and create an empty. So what that'll do is two things for me. It's going to put the object at that location for me, as well as make it a child already, which is what I want. So I'm going to go ahead and call this control trigger. So this is going to be the volume that the player walks into to actually interact with the wind turbine. So I'm going to go ahead and add a component to this. And I'm going to add a sphere collider. All right, so there it is. The collider comes in just like that. So with this collider, it's the collider component itself, pretty straightforward. You can hit this little edit collider box and you'll see these little faces come up or little squares come up. You can just drag them and make them bigger or smaller. And all that's really doing is making your radius larger or smaller. So you can do the same thing by just coming in here and typing in the value you want. And then you can start to move. So you can do one of two things. You can either move the actual game object because it's just an empty, or you can actually start to just use this center attribute and move this to where you want it. Either way is acceptable, but you just want to have it some volume for the player to walk into. Okay, so another one that's really important is this is trigger. So normally colliders are just a collider that the player will collide with on an object, but if you set to is trigger, this is what allows you to use the function on trigger enter, on trigger stay, on trigger exit. This basically will communicate with Unity and say this is a trigger volume. So we're going to need to check that on. Question?
Oh, okay, never mind. You added a sphere
to the empty game object, yeah.
Just remember it never worked with generic behavior.
What?
That is trigger checkbox. It never seemed to work with
Great.
generic behavior.
Good stuff.
Wait, so there's an empty game object.
Yeah. The empty game object is just the collider.
That's on the sphere.
Yep, and then the control station is the geometry, and then you can see I can move this around and the trigger will go with me. So if I want to move the location, it's very easy to do. Question?
You're going that trigger, like, say you walk past it, you turn it on, and you set it to multiple, so you can go in the opposite direction to turn it on.
Like if you're talking about if I leave the trigger volume? Or you're talking about actual direction I'm facing?
I wouldn't say like the direction, like say you walk past that particular item, and that's what triggers it to turn it on, and then you walk, I guess, back in the opposite direction, like out of it, to turn it off. Well, basically, like, can you attach multiple triggers to a single object?
I don't think so. But what sounds like what you'd want to have is your functionality would be you'd have a larger trigger volume that when the player walks into the larger one, you turn on that trigger volume, the one inside it. And then when they leave the bigger one, you turn off the smaller one. Does that make sense? Yeah, because you don't really want to have multiple. The problem with this, and we'll talk about this more in week 4, is if you add, like say I want to add another collider to this, and I add, like say I add a sphere collider, you'll notice that you can't change the name of these. So if you go to actually get the component, like say I want to go get component collider of this game object, it's just going to grab the first one I find. It's not able to discern between the two because they're just named the same thing. Unity doesn't allow you to change the name of components. You just put it on another game object. All right, so we've got our collider here. The next thing we need is an actual script to communicate with what is going on in the scene itself, right? Or how are we actually going to manipulate that parameter we've built already. So I'm just going to create a new script. I'm going to call mine control turbine. And then go ahead and hit create and add. So I'm just going to double click on it to open it up in Visual Studios. And you'll see in the experiment that we've written out this script for you. So it's not like you have to write all this on your own, but we didn't just provide it for you so you can just actually just copy paste. Since it's an image, you actually have to write this out, and it'll give you good practice of troubleshooting and make sure things are working as they go. So what I'm going to do is when we go through, I'm not going to write out all the comments like it's very nicely done in this assignment. I'm just going to explain it, as they go, like why we're doing the things we're doing and why we're using the certain objects we are.
Where's that image at?
That's in the turbine experiment 3. It's like about halfway down.
We're adding this to the collider?
Yeah, we're adding the stripped control turbine to the collider itself.
Well, the empty object with the collider, right?
Yeah, yeah. So I'll talk a little bit about this stuff. If you haven't already, if you're using Visual Studios, go to Tools, Options, and then see Text Editor, All Languages. Yeah, and then All Languages. Turn on your line numbers. This is really helpful for if other people are looking at your code, or even if you're if you join Unity Lab, definitely for the online students as well. If anyone's looking at your code and trying to help you, it's way easier to be like, oh, your error on line 15, rather than be like, oh, right there. Oh, right here? No, right there. Right here? Oh, no, over there. So it makes it a lot easier to just read the code and have people help you. If you're using MonoDevelop, I think it's the same thing. I think it's the same, like Tools, Options, and they don't nest it as far as this. So you're still able to turn on your line numbers if they're not on already. So please do so. And I know that the PGF2 instructor will thank you for that. Question?
How'd you get to the line numbers for Visual Studio?
It's Tools, Options, and then you go to All Languages, or sorry, Text Editor. It was open already. Text Editor, All Languages, and then it'll be right here. So, you guys familiar about what a class is? I don't know if they go into detail with that in PGF1. Yeah? So one thing that's important to note that I'm just going to reiterate is that you always want to make the name of your script in your class, they always need to match 100% of the time. They always have to be the same thing. So if I were to go ahead and change this, say I just delete half of this and go back to Unity, it's just not even going to run because it can't find that it doesn't recognize this class. All right, and you guys understand the start and update functions, what those are used for? Cool. So you guys know that right here, Unity does a great job. This is used right when the level loads or on initialization, this function will get called, and update is going to happen every single frame. So we're going to need a few things in our script to actually get the functionality that we want. So the first thing that we need is we need to gain access to our game object, right? Does anyone know which game object I'm talking about?
The control trigger?
Not quite.
Or the
Let me rephrase. Yeah, so what we need to gain access to the object with the animator, that object in particular. This script that we're writing, this is on our trigger volume. So keep that in the back of your mind, that this is on the same object that has our trigger volume. So the first thing that we're going to need is we need to get access to that game object itself. So I'm going to just make it public. Public game object. I'm going to call this turbine pivot. All right. And then the next thing we're going to need is we need access to the pivot's animator component, right? So we're going to need a private animator to set equal to that component. Private animator. Let's call this pivot anim. So this is just the animator component of our pivot object. All right, and then again, another thing we're going to need is, so we have this Boolean in Unity, right? So in our animator here, we have this toggle spin Boolean. But we can't just change this. We can't just say in our script toggle spin equals true or toggle spin equals false. We need to do a little bit more than that. So we're going to need to create a separate Boolean, and what we're going to do is basically set them equal to each other. So if we change the Boolean that we've created in our script, it's going to change the Boolean in the animator itself. So we're going to create a private Boolean. Let's call this is spinning. You can name that anything you want. I just try and stay away don't name it the exact same thing. Don't name it toggle. I name mine toggle spin, so don't name them identical to each other because then it can start to become confusing. So one thing I like to do, just because I want to make sure I don't break anything, and I like to go back to Unity as often as I can, I'm just going to save my script. And let's see, Unity likes to be a jerk Yeah, and anytime you create a script that way, so if you go to an object and you do add component, new script, what Unity does is it just takes that script and throws it in your assets folder. I'm like, I don't know where it goes. Figure it out yourself. So again, I'm just going to take my control turbine script and drop it in my wind turbine experiment folder just to make sure everything is nice and organized. But now I'm going to come back to my game object with the trigger. There's a hierarchy, control trigger. So now it's basically looking for our turbine pivot, right? That object that is going to have our animator on it. So I'm just going to go ahead and drop that in there now just to make sure everything is ready to go. So pivot, drop that in there. So it's now it has access to this pivot object in the world. Everyone following along so far? If you get lost, please stop me. We're doing real good on time, so we have some time to go over some stuff if anyone has questions. This happens. So this is an issue with Visual Studios. It's just part of the problem or part of the issue to where you need to, it loses the path to the script. So you just need to close it and then reopen it. Yeah, you'll see too, like sometimes here instead of the name of the script, you'll see the path of you'll see the path itself of the script rather than the name. That's because that basically the server, there's an issue with the Visual Studio server, and what's happening is Unity is trying to be a master to multiple different servants, right? It's trying to serve multiple different people or different programs, to where sometimes there's this break in the connection and it loses the path like that. If that ever happens, you just want to close Visual Studios and then reopen it, and you should be good to go. All right, so on start, right when the game starts, what we want to do is we want to get access to our animator component, right? We want to find that animator component and set it equal to this pivot anim we've set up here, right? So what I'm going to do is I'm going to write pivot anim, and then this equals our turbine pivot, right? So this game object that we have here, dot get component. You guys familiar with the get component?
Yes.
Yep. So basically all we're doing is it's going to take the game object we want and then dot get component to get access to that specific component. And now this uses the less than greater than sign or the carets. So inside of our carets here, we want to say what component it is that we want to get access to. Anybody have an idea?
The pivot.
Yeah, that's not a component. That's one of our game objects. Here's a hint right here. What is this pivot anim?
The animation.
Yeah, so the pivot anim is an animator. So we want to set this one, this pivot anim is going to equal our pivot animator. Right, and we all know that that is what holds our idle and our spinning animation that we've created, as well as the parameter. Right, so now I'm just going to get component animator. Now this is a function, so we need our open and close parentheses, and then put a semicolon at the end. All right, so now our pivot anim, this animator here, this private animator that's only in our script. You guys know the difference between private and public? Yeah? Yeah, so private, you're only going to have access to that inside of this script. Public, anybody can get access to it. So if you want to access it from another script or you want to change it in a different class, things like that, you want to set it to public. So you also notice the reason that I have public here, that's the way I can come to Unity and drag and drop in there. But you'll notice I don't actually have in here, I don't have this Boolean is spinning in this animator. If I were to go ahead and make this public and save this, I come back to Unity and then just refresh, give it a second. Now you see that this is that Boolean right here that I can turn on and off. But you don't want to do this for everything. More often than not, you want things to be private just so you don't mess with them or someone else doesn't come in and break it. You only want to expose certain things that you actually want people to be adjusting. So that's why more often than not, just keep everything private and then use it sparingly. All right. Okay, so the second thing, the one line that we're going to need in the update function is we constantly want to be setting our booleans equal to each other. So we can't do this on start. We can't just say, is spinning boolean equals the parameter inside of this animator, because that's just going to set it equal once and then let it be. We want to constantly be making sure that they're the same, because we're going to be able to turn these on and off. So this is going to be in our update function. We're just going to say is spinning. So this boolean we've created up here, right here, this equals our pivot anim dot get bool. So this is a function you'll get pretty much off of an animator component. So if you do the after any line that you write, if you put that period, that's called the dot operator. This will basically show you all of the different things that you have access to. So we have all these different functions that we can call off of this pivot anim. So what we want to get the boolean. So we want to first get it and find it, and then later on we can set it. So where is it? Get bool. So then if you hover over this, you'll see there in the parentheses it's saying the string name. So what is the name of the boolean that we want to actually gain access to? Anybody know?
Toggle spin?
Toggle spin, yep. So the toggle spin is the one in the, bless you. Toggle spin is the one in the animator itself, and we're setting it equal to this private one here. So now anytime we change this toggle spin, it's going to also change is spinning. All right, and then semicolon at the end there. Alrighty. So now the next things we're going to need is to write our different functions. So I'm going to start out with, I'm going to do a void on trigger enter, and in the parentheses I'm going to write collider entity need the curly braces. All right, now in here on our on trigger enter, I'm just gonna check for the player. So what we're gonna do is write if entity.tag double equal sign player. All right, so the difference between a single equals and a double equals. So a single equals sign, that is an assignment. You're saying this thing equals this other thing. The double equals sign, this is a comparison. So Unity is this just checking to see, is this object equal to player? Is this tag equal to player? It's not assigning it, it's just going to check. So if it's there, it's going to execute what we're about to write next. Another one is if you do the exclamation point equals, that is checking, is it not? If it's not player, do the rest. So that's the difference between assignment, single equal sign, and comparison, which is the double equal sign. Really helpful to understand the difference. And that took me way longer than I should have to actually realize what assignment is and what a comparison is. But definitely good stuff there. So now in here, all I'm going to do inside our if statement is I'm just going to write a print to make sure that this is working. So I'm just going to write print the player has entered the trigger. All right, and now what I'm going to do is I'm going to copy this, because definitely when you're coding, work smarter, not harder. So I'm just going to copy this 2 times. So we're going to have 3 functions. Now we don't all want them to be on trigger enter. I'm going to make this one on trigger stay. Oh, I do. Thank you. Right here. Okay, so now the player has entered. I'm going to put the player is in. And then down here, I'm going to say the player has left. So this is just going to check and see that our trigger volume is working. So don't skip this step. Don't think you can just write this whole script and then try and troubleshoot it. You're probably going to get yourself overwhelmed that way. Do it in small steps like this, and that will just make sure that you can catch a mistake as soon as it happens, rather than waiting a long time before you can fix the issue. All right, so now I'm going to actually play. And there's my console down there. So come over to the wind turbine. So now if I enter the volume, you'll see that there's that 1 there. So that 1 there. So I entered the trigger volume, and now as long as I'm in the trigger, this is going to keep firing off. So notice this is keep going up, keep going up. Now I'm going to leave the trigger. And now it tells me that the left, the player has left. So what does this tell you guys about these different functions? The on trigger enter, on trigger stay, and on trigger exit. Angelo?
Basically, well, with the enter, it's telling you how many times you entered it. When you're in it, it's counting the seconds that you're in it, and when you leave it, it's how many times you have.
Cool, exactly. So what is that, when you're thinking about designing things, let me try and rephrase the question. Why would I not want to put the input, the player pressing E, inside of my on trigger enter? Just looking at the numbers and how it's functioning.
Every time you click,
Not quite. So if I put in an on trigger enter, so with on trigger enter and on trigger exit, it's only happening 1 frame. You only ever enter the trigger once. So if you put your press E on trigger enter, the player literally needs to press E on the frame, the perfect frame that they enter, which is nearly impossible. And 1/60th of a second to hit E at the right time. So that's why you wanted to use your on trigger stay. So as long as I'm in the volume, this is going to keep checking. Now I can press E at my leisure. So on trigger enter and exit are definitely important and useful. You can have, when the player enters, turn on lights or slam the door shut to just kind of screw with their head or do different things. But for input and things like that, you always want to be using on trigger stay. Alrighty, so what's up?
I have null references. Like, I don't know where those came from. They're a part of my control turbine.
You probably haven't plugged in your pivot object. Drag and drop in the turbine pivot. All right, so now let's add some actual functionality to our scripts here. So we know that the stay, this is where our interaction is going to be. This is where the player is going to press E. So let's...
Just the pivot?
Yep, just the pivot object. The object that has your animator. So now in here, we're going to actually check for if the player has pressed the button that we're looking for, right? So another if statement. So if the player has entered, if the tag that's entered the collider is player, it's going to execute this next if statement. So then if it's the player, and then if their input has been provided, so we're going to do input get key up. So here you'll see that there's three different get keys, basically all the same thing. So get key is going to be basically as long as you hold down. If you get key would be if you want to like hold down something and repeatedly do it over and over again. Get key up is basically only going to happen when they let go of the key, and get key down is only going to happen like once as soon as they push the key down. We're going to go with key up for this one. But you can try out the differences and test out. What's that?
Key up or key down, would it matter?
It's very marginal differences. Like there can be it could be in the use where you want the player to hold down a button and then let go at a certain time or things like that, like timing events. But they're in this case they're definitely replaced. They're interchangeable.
I think like if it's a speed thing, you would probably want to use key down because it should be faster. Because the player actually pushing it down is faster than release.
Yeah, if you want to use key down, that's totally fine. Yeah. So then inside here, inside the get key up, we want to say what is the key they want the player to press. So you'll see here's this key code, and then you'll do the dot operator after, and here you'll have basically access to every single button on the keyboard as well as these joystick buttons. These would be if you were like hooking up a controller or things like that. So basically you have access to every key on your keyboard. But we're going to go with the standard interact key for PC games, which is E. All right, so if the player presses E, it's going to execute the rest of this. But we're also going to check for another condition is met. So we can do this in an if statement is do the double ampersand. So this is saying if the player presses E and this other thing, then do the rest of this functionality. So we're going to check for this is spinning value, right? So we're going to say and is spinning. Oh, can't type. Thank you, autocorrect. If this is set to false, then go ahead and execute the rest of this. Move this for now. Let's put this inside here. Okay, so if the player has entered the volume and they press E and this is spinning value is false, which we know is spinning is set equal to our toggle spin value. Anybody have a shot as to just logically what we want to do next? You don't have to do the syntax, but what is the next thing we want to do?
Start the animation.
Okay, and how do we start the animation?
Set is true.
Exactly, right? We just set our Boolean, and that's going to change the parameter. And actually what we want to do is not change is spinning, but we're going to change the actual toggle spin, because we know that when we change toggle spin, it's going to change is spinning for us. So definitely along the right line. So we're going to do a pivot anim and do a set Boolean. So here you can see this goes back to how you can use a trigger. So here you can do a set bool, right? So here would be if you hover over this, it's going to say the name of the Boolean you want and also the value, right? So here we're going to write in toggle spin and then set it to true. But if you go down this list and look at set trigger, so basically all this doing is the same thing as set Boolean, is the same thing as set trigger, but here it's just looking for the name. So it's just going to trigger that to happen, and it would go ahead and go on with that condition. So that's how you could use a trigger as opposed to a Boolean. So it's a little bit more streamlined, but it's, again, used in different situations. So I'm going to go ahead and do a set bool, and now in here we're going to write the name of our Boolean, so toggle spin. And then also, we want to say what do we want to set it to. We're going to set it to true. And go ahead, and then I'm going to write print the player. I'm going to just change this. The player has activated the turbine. Save that. How are we doing on time? Looking pretty good. Alrighty, so now when we test this out, wrong way, I should be able to turn on my trigger now. So let me go ahead and pull up the animator window so you can see that there's my toggle spin there. So I walk up to this. It told me I entered, and now I press E. And now you see, there you can see that the toggle spin is now set to true. This print line tells me that I've executed my functions properly, and then also you can see that the turbine is actually spinning. And now you can see if I press E, again, nothing is happening, right? Now we need to set up to go the opposite way, right? To basically just turn it off. So now that we have this system set up, it's pretty straightforward. All we need to do is copy this if statement right here and plop it right down below here. So anybody have a shot of what we need to change? Because we can't just copy and paste and call it good. There's a few things we need to adjust. Jacob?
The change is spinning to true.
Okay.
And true to false. The set bool to false.
Exactly. So we're just going to go.
Deactivated.
Yep, exactly. Throw this deactivated in there. Perfect. Save that. Another test. So now it'll turn on, activates. Now if I turn it off, it stops, and everything looks good to go from here. So now we're communicating via script with our animator, right? Because that's all we're doing is turning this on and off. That is what our script is doing in a nutshell. So one thing I want to point out to everyone, just to understand for clarity's sake, is that these are all just names we've come up with. So if you wanted to change this is spinning to, I don't know, pineapple, that's totally okay. As long as down here you say this is also pineapple, And then also down here, this is pineapple. That's totally fine. This is totally just a naming convention. These aren't tied to anything in Unity. This is just your naming convention. Same thing here for entity. If you want to say like collider Bob, right, and then just do if bob.tag is equal to player, this is going to execute the same way. So I don't want you to think that these names are specific to any wing. It's just as long as you are understanding them and assigning them certain things. And yes, obviously you don't want to be doing things like this, like Bob and pineapple and things that are very difficult to read, because if you were to hand this off to another, like you're in a team and you want someone else to work on it, or you come back to it 5 or 6 months later and you're like, what was I thinking? You still want it to be understandable, but I just want you to understand that the name is just a name, and as long as it's consistent, it doesn't have to be specific to anything. All right, so the final step to the last experiment is we need to add some interaction or some audio to the game itself, right? Just to give the player some feedback when they've actually pressed the button. So what we're going to do is on our control trigger, so go to our hierarchy and make sure we have our control trigger selected. We're going to add a new component. Let's go ahead and add an audio source. All right. So here on the audio source, this is looking for the clip that's going to play. So what we're going to do is just find in our project, and if you've imported that package, you have this click and wind loop, these two sound effects. So I'm going to go ahead and hit click. Go ahead and select that. And now if this play on awake is turned on, it's always a good idea and a good habit, especially if you're importing sounds from the internet or making your own, just to play the sound and make sure it works. So everyone hear that click right when the game started? So that's just testing that the sound is working and the audio source is hooked up properly. So we don't want it to play on awake, so we're going to turn that off. And then down here, you can start to mess with the 3D sound settings to make it, when the player is near it, they hear it a lot louder, and then when they're farther away, it's like they hear it very muffled. This is good for like motors or generators or like cars or things that you can hear them, but it's the volume is different based on how close or how far away you are. So play with the min and max distance on some of these. And there's a lot of trial and error too. You can play with the curve itself, or you can change the roll-off to be more linear. And really mess with this. Or again, though, this is reading a graph and being able to manipulate it. So go ahead and feel free to adjust that as much or as little as you'd like to. So what we're going to do though is get our audio source working with our script. So just like we have for our animator, right? We need to gain access to that component. So we're going to need a private audio source. Not audio chorus filter. And let's just call this control audio. All right, so now in the start function, we can do a lot of what we did right here. So where we can say our control audio equals the component of a certain object. So one thing to keep in mind is that this control audio, this audio source that we're getting, pay attention that it's on the exact same game object as our script is, right? These are on the same game object. So here we don't need to say turbine pivot or some other object .get component. We can just say get component because these are the same object. Does that make sense to everybody, the difference? What? Yeah, we're just going to say what is the name of the component we want, and that's just the audio source. So after that is set up, and now that the audio is equal to this audio source, it's very straightforward as we just come to our script in here where that this is happening. We can go ahead and just say control audio dot play. All right, and let's just go ahead and copy this, the whole line, and let's paste it into our other. So this is going to click when we turn it on and click when we turn it off. All right, save that, test it out. Now I walk up to it, press E. Hear that click, the animation starts. Press E again. You hear the click and it turns off. Good stuff. So the final thing we need to do is we need to add one more audio source. We want to put it on the pivot object itself. So we want to hear a wind sound effect when the object is on, right? We want to give the illusion that there's wind and just giving a little bit more ambient noise. So select your pivot object. Make sure you have the right one selected. And again, let's add an audio source. Okay, and now on the clip, we want the clip we want, so you can hit the little button or you can just drag and drop right in there. So this one, again, we don't want it on awake. We're going to turn that off. All right, so again, this is very similar to what we just set up, so it's a lot of copy-paste and just changing some of the names.
Go back down to the,
Sure.
no, on the script. Go back down to the control audio guide.
Play.
Oh, okay. I was trying to figure out what was wrong with it. I figured that.
All right, so we're going to just change this one to, let's call this wind audio. And now this one, this is on our turbine pivot, right? So remember, we put this audio source on our pivot object. So we're going to need to actually, to get that, get the game object first, then the component of the audio source. All right, so then with that in store, all we need to do is come into our here, into the, when they turn it on, and do wind audio dot play. And now we don't want it to continue playing when they turn it off. We want it to actually stop. So this is just straightforward as wind audio dot stop. All right, and then save this. And now one thing we do want to double check is make sure you turn this loop on. So we want it to, otherwise it's just going to play once and stop. We want it to loop over and over again and hear that wind audio as long as it's on. Let's just turn this up a little bit. So now I should be able to walk up to this. It'll turn on. It is a subtle noise. Hear it though, just that slight humming wind noise. I turn it off and it stops. All right. So that is all you need to do for the turbine experiments. That is all three of them in a nutshell. And now what you can do, bless you, is if you want to, is now you can group all this. This isn't in the instructions, but you'd asked before about the prefab itself. So you can go into your hierarchy. So we have this control station and this wind turbine here. We should be able to just drag our control station and drop it right in there. And now we have this one large prefab, or one thing that contains all of it. Let me just test it real quick to make sure I didn't break anything. Always a good idea. Never know what can go wrong. Yeah, everything looks good. So now that is one contained system, right, or one contained asset. So what you can do now is, now that you have that, you can go ahead and create, you can just delete this one or create another prefab if you'd like. But this will now contain the whole system, right? It'll contain the trigger volume and the audio and the control station itself, to keep everything, all the functionality in place. So that is one thing you can do to have this ready to go. Then it could just drop this in the world, and it comes in with the control station and everything ready to go. All right, so I'm going to go ahead and save my scene. Come back to Perforce. Let's see, so I added some new stuff, right? I added the script, and I also added, take a look, I added the sound effects and my new prefab, so I could delete the old one if I'd like. Just going to grab this stuff. See, another even fancier way to do this, you can drag this whole folder into the default, and it's going to basically check out the things that that you didn't, that were modified, and then also add the new, all the stuff will be marked for add. So I can go ahead and submit. So you can see there's a lot of ways to do the same thing. You can use reconcile offline work, you can check out, you can drag and drop. It's really up to you. Just as long as you understand what you're doing, you'll be good to go. So now let me go ahead and show you guys some examples of the entryway itself with the last few minutes we have here. So you'll see in the entryway, here's the assignment itself, and in here I have a few just images of some of the entryways from previous months. So this is you can do something more traditional, and here is one that this student did that I was so blown away and impressed by, and I was like, why am I getting so excited? This is just a doorway. But he put so much detail and information into this that it was just really impressive. So like he put like the hinges actually had 2 plates and a pin, and they animated one opened and closed. And the door itself had like a knob, and I can actually just play some of these. Yeah, this is another one. So you can do something more traditional. This is the requirement, like just a base entryway or basic doorway that you'd see in a game or in a world, just showing and displaying everything you've learned from the turbine experiments. Because this is, we don't walk you through step by step how to make a doorway, but we basically just did by going through the wind turbines, right? Setting up the complex game object, animating it in the proper states, and then getting the script to play the audio as well as interact with that parameter we set up. You'll be able to animate this door as well as anything else you want in your level after going through those experiments. So this one down here, a little bit more unique. Obviously, is not the same traditional door, but functions all the same, still performs the same way. And now here is another really good example of something that was very creative and well done, and this is all done with level blocking meshes. But let me go ahead and actually play some of these for you guys. So I don't think I've yet included them on the depot, which I'll try and do if you want to play through them yourself. I'll try and do that over break, because they're definitely good to experiment with. So here was the circular one, and now this one, when you pay attention to the animation, that wasn't 8 objects with 8 separate animation controllers. Remember I showed you you're able to animate all the children objects? So this is just one animation, and he's just animating 8 pieces rather than say get component audio, get 8 different animators and play them all at once. You can set it up in a way where it's just one smooth, simple animation, just like that. So good stuff. There, the audio, he did a great job. The audio really matched up well with the motion itself, which isn't an easy thing to do. Let me show you the skull, because this was one that was very technically and creatively well done, and also he uses a trigger that we covered a little bit. Just got some ambient music. Go up to this and press E. You see the eyes light up. Really good feedback. Definitely really good stuff. So now it's open. Now this is where the trigger comes in. So if I walk up to it, so that's just a trigger, right? So trigger, change from one state to the next, play the animation, return back to that state. Now you can walk through. He did such a great job, and then he made this. This always gets a laugh, so I always show it. So now I can't get back out, which you don't want to do, but overall that was a really well done entryway and shows the creative side of things. So you can stick with something more traditional. You can do a creative. You're not going to be penalized or given a free pass one way or the other. I'm still going to be grading you on the same things. If you want to do something more creative, you still need to have a frame of some kind. You need some type of part of the object that isn't moving. So you saw there in the skull, to where the head and the eyes and things, they don't move. It's just the jaw opening and closing. So the head itself, that's still the frame. And also you need some type of handle or interaction point. So on a normal door, you'd have like a handle where when I go and play this or grade these, I need to know where it is I'm interacting with. What's the point that I'm able to interact with, so I understand and I can test how big or small your trigger volume is. So it could be a button, it could be an actual handle on the door, just something to represent this is the spot you walk up to interact. Does that make sense? Cool. Now real quick, I'm just going to show you guys the example I've been working on, still not completed with all the other things going on. It's hard to fully finish this, and I really went above and beyond with what I'm working on just to showcase overall what's possible with what you guys just learned. So let me pull up my scene. Hub. So this is a little bit more elaborate, and let me maximize this. So it's a little bit more elaborate because mine is basically locked. I set up just a little bit more functionality to check for something. But here's my entryway. I've been working with nothing but level blocking meshes to showcase pretty much the amount of detail and information you can get out of just the level blocking meshes. So my doorway or my entryway here it's locked right now. You can't get in. So I'm pressing E. You can't access it yet. But now I can come up to this, and I need to pretty much get these in the right combination to open and close these. So if I get these in the right order, you'll see now that the little button opens, and now I'm able to interact. And don't mind that gear in the background. It's not supposed to be doing that, but now I can interact. And now the button turns green. That's done with an animation event in my actual animation. And there you can see the door opens. I can progress to the other side and interact over here. So that was just something I was showcasing, that little cube there, that I just put in there to showcase, like, you could just animate that like that now, and then later you could replace that with a particle effect or replace that with something else. I just wanted to show player feedback that it was working, and it's all done with an animation. So if I go ahead and show you my animation itself, it looks like a lot of information at once, but you'll notice here's the animation right here. To where, because I've set it up in a way to here's my animator, I have access to all the children below it, and I've been animating all the different objects in here, right? So here's that glass case. Here's the button I'm animating back and forth. So you have access to all the children objects. So think about logically how you're setting up the game object itself. Now here is an example of those. Real quick, I'll cover here's my example of the animation events. So I have just a very simple script on the objects. Remember, you need to put the script on the object you're animating. So here I just call it change button color. So basically, I have all this stuff, but here are these different functions, right? So basically, turn the button to red, turn it to green, and then turn it back to red. And all I'm doing in here is basically switching the material from here. The material is green, and then I'm basically setting it to green. I'm setting both of them to green, and also I'm changing the color to green as well to give this illusion that the color and the material to give the whole effect. And so basically here it's red, and I'm changing the intensity. Here it's green. Here it goes back to red, right? So then that script is on the same object. And so now if I go ahead and add a new animation event, no!
Sorry.
You're fine.
I'll wait.
So now this little window will come up. So then basically you can select what function you want to call at that time on your animation event. So you can select that and then pretty much move this into place, and then you can hover over them and see the function that's going to call. And that's how I was actually changing the light intensity and the button color. Eric, did you have a question? I saw your hand up.
I was asking how you made the glass in the panels that you had, just how you, because I saw that there's glass there. I just wanted to see how you made it see through and everything.
Yeah, that was just, it's just it's a level blocking mesh with a material on it that I pretty much just made a material with a color and some transparency.
Okay.
Pretty straightforward stuff, yeah. Alrighty, so all that is recorded. You guys will have a live video to walk through the wind turbine experiments if you want to. So you guys are doing your reviews, right?
Yep.